Question 2. When a driver hits the brake, his car decelerates at a uniform rate of 2 meters per second square. His car stops in 9 meters. So the question wants you to find how long does it take for him to stop. So again, a velocity time graph. The car was initially at a certain velocity which we don't know, but we know that it decelerates at a uniform rate of 2 meters per second square. So the velocity time graph is a straight line with a gradient of minus 2.0 meter per second square. We don't know the time, so let's just label t1 and the initial velocity as v1. What we do know is that the area under the graph, which is the distance traveled, is equals to 9 meters. Distance traveled before car comes to a stop is equals to the area under the velocity time graph. So this is just half times t1 times v1. Okay, we don't have the value for both t1 and v1, so what can we do? What we know is the acceleration equals to minus 2.0 meter per second square. So v1 minus 0 over 0 minus t1 equals to minus 2.0 meter per second square. Okay, over here we're just trying to find the gradient. You know, this point is t1 comma 0. This point is 0 comma v1. So gradient is simply y1 minus y2 over x1 minus x2, right? Which is v1 minus 0 over 0 minus t1. So this is what I've done here. So we know that v1 equals to 2.0 t1. So that's the relationship between v and t. So now the question wants us to find how long does it take him to stop, right? Over here we got a equation with two unknown, and we know that this equation is equals to 9.0. So what we do now is to put this relationship into this equation. Okay, if you do that, 9.0 equals to half times t1 times v1, right? This is equals to half times, we want to keep the t1 because that's what the question wants you to find. So you substitute the relationship here into v1. So this is half times t1 times 2t1. So t1 is equals to plus minus square root of 9.0, which is equals to plus 3.0 or minus 3.0. This is not applicable because we are talking about time, so time cannot go into the negative. t1 is just 3.0 seconds. So that's the answer.